All right. Next, we're going to do another one with cylindrical coordinates. We're going to evaluate this integral by changing to cylindrical coordinates. So right now, it's written in Cartesian coordinates. Okay, and you've got these boundaries. And what we have to do is, really the problem is, how do we interpret these boundaries? Okay, so, well, x goes from -5 to 5. So, x going from -5 to 5, okay, y goes from 0 to 25 minus x squared. Now, what is that, 0 to 25 minus x squared? I wrote it out here. If we take y equals 25 minus x squared, that's equivalent to y squared equals 25 minus x squared, or, if you will, x squared plus y squared equals 25, with the caveat that y is positive. So it's this circle in the xy plane, and it's just half of it. Okay, that's where I'm getting that from. Now, what's our other boundary? 25 minus x squared minus y squared. That's a boundary in z. So, if we think about that, let me write it out here. Z equals 25 minus x squared minus y squared is the same as z equals 25 minus r squared. Okay, because x squared plus y squared equals r squared. So, that's how we get this. So, rewriting the integral. Square root of x squared plus y squared is r. R dz dr d theta is our dv. Z goes from 0 to 25 minus r squared. R goes from 0 to 5. That's this 0 to 5 here. And then now, we're not going all the way around. We're just going halfway around. Okay? Remember, the upper half. So that's 0 to pi. If you want to think about that two-dimensionally, think like so. Not like so. Why is it getting rid of... Why did it get rid of things not in order? I don't know. Computers. Think of it like so. Okay? Alright, let's go to the next one. Now we're going to get some spherical coordinates in. So, use spherical coordinates, that's the question, to find the volume within the sphere x squared plus y squared plus z squared equals 81, above the xy plane, and below the cone z equals square root of x squared plus y squared. Now, I wrote here this can easily be done, or be easily done in both spherical and cylindrical coordinates. Let's get rid of that easily. Okay? It can be done in both spherical and cylindrical coordinates. Okay? And oftentimes, in years past, I don't think that's going to happen this semester. That is, if you're listening in the semester of coronavirus, because I might use these videos in the future. But if you're listening in the semester of coronavirus, I do not think I'm going to ask this question. But otherwise I would ask the question on a test. Do it both ways. I've done it in the past. I could easily do it again. Okay? So, let's start by doing this in cylindrical coordinates. First thing, I'm going to actually draw the picture. So, x squared plus y squared plus z squared equals 81. I could write that, I could think of that in cylindrical coordinates as z squared plus r squared equals 81. In spherical coordinates, I've written it over here but I haven't done that. That's rho equals 9. Okay? Think about it. That's x squared plus y squared plus z squared is rho squared. So rho equals 9 is that boundary. Okay, so here, we're going to set it up first in cylindrical coordinates. So just let's look on the left-hand side. Okay, see how much easier it is in spherical, though? So, first thing is we have a little split here. Okay, we're going to integrate from here to here, and then from here to here. I tried to make it look okay. Here you can see this is the thing that we rotate, and that's corresponding to this integral. Okay. Z goes from 0 to r. R goes from 0 to 9 square roots of 2. How did I find 9 square roots of 2? Well, I took z squared plus r squared equals 81, and z equals r together. Okay. Z equals r, that's the formula for the cone, right? Okay. And that gave me they intersected when r is 9 over square root of 2. So, this integral corresponds to the region that it's with. This little piece, from 9 square roots of 2 to 9 in r, theta goes from 0 to 2 pi. That says it's going to be going all the way around. That's my attempt to do that. Okay. And then z goes from 0 to 81 minus r squared. So z goes from 0 to 81 minus r squared. Oopsie daisy, I should have had a square root there. Well, luckily it didn't go out without it, so it's going to have the square root on there now. Okay, that's why it's a good idea to maybe check your answers twice. Okay, now if you do this in spherical coordinates, it actually is almost trivial. R goes from 0 to 9. Phi goes from pi over 4 to pi over 2. Think about that, pi over 4 to pi over 2, because phi is the angle down from this axis. Okay, pi over 4 is that angle, pi over 2 is that angle. And then theta, of course, goes all the way around. Okay, so my suggestion, if you're really, there should be a d theta here that got marked off. But my suggestion is if you're very motivated, go ahead and try to do this both ways and see if you get the same answer. Here's another sort of interesting point. I don't know why, there's no reason, but this integral and this integral actually give you the same value. So that's something you should check for. Okay? All right, that's it for triple integrals. I will see you all in class on Monday.